Okay, students, this is our Unit 2 review, Part 2. So it's covering the remainder of Unit 2, which is 2.08, 209, 211, and 212. Let's get right into it. The information for 2.08 and 2.9, it's talking all about triangles and similarity. And so 2.08 was actually this postulate right here, and it focused on the angles. Okay, so you see this angle-angle similarity postulate. And this postulate says if two angles of a triangle are congruent to two angles of another triangle, then the triangles are similar. And so you can see over here with our example that we have these congruency symbols right here in the corner. And that's a little bit hard to see, but there's actually two marks there. So it corresponds to this angle D, which has two marks. And then right here on C and F, they have one mark, so those correspond. And so knowing that those two angles are congruent, meaning they're the same, we can then say that these two triangles are similar. And then 2.09 deals with the sides, and so you can see here that this is the side-side-side similarity theorem and the side-angle-side similarity theorem. And so this one right here says if the three sides of a triangle are proportional to the three sides of another triangle, then the triangles are similar. Now, up here with angles, we talked all about being congruent because remember, when things are similar, our definition up here, it means that they're the same shape. So the angles have to be the same, okay, for it to be the same shape. But for it to just be similar does not mean the sides have to be congruent. So as you can see over here on all of our pictures of our triangles, those are not congruent because they're not the same size, but they are similar because they have the same shape. Okay, and so down here, this word proportional, meaning that these sides can match up and we can write proportions using them. So we highlighted them in different colors. Here you see the green AB, and it corresponds with this DE. And so we can say that we can write that as a ratio. And then the same thing goes for AC and DE and BC and EF. All right, side angle side says if two sides of a triangle are proportional to two sides of another triangle, and if their included angles are congruent, so the one in between them, then the triangles are similar. So you can see here that we're talking about these angles being congruent, C and F, and we're talking about BC and EF being proportional to the other side, D, F, and AC. And that angle is included in between there. Okay? All right, hopefully that makes sense. Let's look at some questions, some examples. First of all, this is 2.0 talking about angles, and so we're going to strictly just talk about angles on this slide and deal with this angle-angle similarity postulate you see down here. And so here it says that we have these two triangles, and it says that they're similar. That's what this symbol in between them means. It's this squiggly line meaning similar. Okay, oh, that's not a very good squiggly line, but there's my squiggly line meaning similar. So what that means is that the corresponding angles have to be congruent. Now, first of all, I want to bring to your attention that we have, and I'm going to kind of try and point to them, we have angle A, and that's the one we started with when we named the triangle. And we also started with angle E on the second triangle. So what that means is that angle E and angle A, so angle A, has to be equal or congruent to angle E. Okay? It also applies for the other angles. So because B is in the middle, up here, and F is in the middle, okay, then we can say angle B is equal to angle F. Okay, and so we know that if we have one of these, we can find the other one because they are congruent. And the same thing applies to angle C. So angle C is congruent, or angle C is congruent or equal to angle G. All right, so that tells us a lot because what it wants us to do is to find the missing angle measure. And I know that A is 81 here. So guess what, guys? If A is 81, we also know E is 81, okay? And if G is 29, we also know C is 29, okay? And so knowing this idea and having the definition of a triangle saying that all the angles add up to equal 180, we can go back to the idea that if I take 180 and subtract the two angles that I know, I will have the third angle. And so I go 180 minus 81 minus 29. And the answer to this is going to be the answer to angle B, which is also the answer to angle F because they are congruent. And so let's go ahead and do that. 180 minus 81 minus 29, and we get 70. And so we know that this angle B, which is also the same thing as F, has to be 70. So that is the answer, and that's what we were trying to find. Okay, I hope that makes sense. Let's move on to another question, finding missing angles, but you can see that this one is different because it has this right here. It does not say angle C equals 50. It says that angle C is to the measure of angle M. Okay, so let's make sense of this. First of all, you can see that A and L are congruent. They match up in order. B and C, or B and M, have to be congruent, and C and N then have to be congruent. Okay, and I do that because we have some things missing here and some things that we know. So we're working within two triangles. We have A and C here, so that's in the first triangle, but then they're asking something about the second triangle, okay? But if you notice, M and B are the same. Well, B is what we're missing up here. So I'm going to say angle B is equal to angle M. And we don't know what angle M is. That's what we're trying to find. So I'm going to say that this actually equals X. So angle M equals X. And if angle M equals X, then right here where it says angle M again, we can write an X. And so let me go ahead and rewrite. The measure of angle C is no longer 2, the measure of angle M, it's actually 2X. Okay? And so going back to what we did over here on this side, where we subtracted from 180, I'm going to do something kind of like that. So I have three angles. I have angle A equaling 111, angle B equaling X, and angle C equaling 2X. And so I have all three angles, and I can go ahead and add them to equal 180. And I do that because we have some x's missing here. I can't just go ahead like I subtracted on the other side. I have to actually show my equation because I don't know what x is, so I can't just subtract. All right, so that equals 180. All right, from there then, guys, we're just going to solve this equation. So I'm going to get my like terms together, which means I'm going to put 2x with 1x and make 3x. And I still have plus 111. And it still equals 180. Okay, so as I go ahead and solve this equation, this is just like solving any other equation. I'm going to go ahead and draw my line here through my equal sign, and what I do to one side I do to the other, so I'm going to isolate that variable. But first I have to get rid of the 111. The opposite of a positive 111 is to subtract it, and so I take minus 111. And when I subtract 180 and 111, I believe it's 169, but let me make sure I don't want to tell you wrong. Yep, so this is, oh wait, it's just 69, not 1. Yeah, that would be silly. Okay, and then that equals 3x. And my last step to get x by itself is to then divide. And you can see that x equals 23. So we just did 69 divided by 3, and we got 23. And so that is the value of x. Now, let me go ahead and refer back to what x is. So x is representing B, which is also representing the measure of angle M. And that is what we were trying to find. So therefore, 23 is our answer. All right. Moving on to 2.09, which is talking all about the side lengths now. So you can see we don't have any angle measures here, we just have side lengths. So let's go ahead and look at a question like this. This one says that these two triangles are similar, kind of like the last questions. But this one wants us to find the length of AC. So I'm going to put an X there because that's what, oh, not there. Darn it. Let me erase that. I'm going to put an X here because that's AC. Okay, that's what we're trying to find, the length of AC. And to do this, so there's a couple ways to do it. I tell my students to set up proportions because proportions will always work, no matter what. If you're given a single X, or if you see over here in a second, we're going to look at one that's a little bit more complicated, and there's not just a single X there. So proportions will work all the time. Some students say, well, Mrs. Guyman, though, I can see a relationship. Like, I can see the scale factor. I can see how much bigger this is because I know that from here to here, they times it by 5, right? Oh, but not from there to there. I'm sorry, we want from, I was like, that's not working out. We want, I gotta match up sides, man. From here to here, okay, they times it by 3. And I knew that didn't work because it wasn't working from the other one. And so I can say, okay, well, I'm assuming that this one, this bigger one is 3 times bigger. So then I can say, well, if this side is 12, then I know what this has to be because I'm going backwards and dividing, okay, by 3. But I want to show you by setting up a proportion that we're going to get that same answer. Okay, so the important thing is when you set up proportions that you match up the sides. I want to match up this side with this side. Okay, because that's the corresponding side. So as I do that, I'm going to write it as those being both on the numerator. Okay, so I'm going to write it as that being on top for both of my sides. Okay, and then I can see that I'm going to go ahead and match up BC and EF. Okay, and so that's BC is on the side with X because that's the triangle it's located on, and 6 goes with 12 because it's located on the second triangle. All right, so now you can see that we have a proportion, so we cross multiply both of these. 2 times 12 is 24, and that equals 6 times X. Well, 6 times X is just 6X, and then my last step here is to get X by itself. Okay, is to divide, so I divide by 6. And what I do to one side of the equal sign, I have to do to the other. Oh, that 6 is struggling. It's not wanting to write a 6 for me. Okay, so you can see that 24 divided by 6 is actually 4. And so I can say that X equals 4 here. And indeed, that does match up what we did if we were going to go backwards and divide by 3 by using the scale factor. Okay, and so that dividing by 3 is just kind of a shortcut if you can see it. If you can't see it, guys, I promise if you set up a proportion, every time it will work, okay, no matter what. All right, so then let's move over here to the right side of the screen, and it wants us to find the value of X. Well, if you notice, the value of X is part of one of our side lengths. And so this is the same idea except for it looks a little bit uglier, right? So I'm still going to match up sides. I'm going to write 3X minus 1 over 11, okay, because I like to stay in the same triangle as I write a ratio. And then I'm going to match up 5 on top because it goes with this side that you see here that we're trying to find. And so the 5 goes on top here as the numerator, and the 3 goes on the bottom. Now, I picked this one because it's not quite as easy to see. Even if I was to look from here to here, I can't really tell what it's being multiplied by to get that, or what it's being divided by, okay, to go back and forth. And so I really wanted to show you with proportions. This way is easy to multiply, okay, so 5 times 11 is 55. And I'm going to write it on this side of the equal sign this time. And then, oh, this one's tricky. When I multiply 3 times this, guys, we have to write it so that it looks like this. 3 times everything on top. So I'm going to put that stuff in parentheses, okay? And so I'm going to see it as 3x minus 1. And then hopefully you remember the distributive property from last semester, but this means when you see it out in front like this, it means to multiply or distribute through. So it's like you're delivering that 3 to everything on the inside, and when you deliver, you multiply. So 3 times 3x is 9x, and 3 times -1 is -3. Okay, so now you see we have 9x minus 3 equals 55, and we're just going to solve this equation. So all of these questions are bringing us back to solving equations. See how important they are? When I do the opposite of subtracting 3, I add it. And so I do that to both sides. And on this side, I'm left with a 9x equaling. Now, 55 plus 3 gives me 58. Ooh, and this one doesn't look very good because I don't think that it's going to come out as a whole number, and that's okay. We can have decimals, we can have fractions. So the opposite of timesing is to divide, so I'm going to do 58 divided by 9. And when I pull up my handy-dandy calculator, 58 divided by 9 is, as a decimal, 6.4444. So x equals, we're just going to say 6.4. Now we could have left it as 58/9. On your test or your quiz, it's either going to be multiple choice, and so you'll be able to pick the right answer, or they're going to tell you what to round to, or it's going to come out as a whole number, okay? All right, so moving now to 211 and 212. I put up these on the same page again because, once again, this is just like a combination of these. So this is called the side-splitting theorem, and both of them deal with the side-splitting theorem, okay? So the first part, 211, mainly is talking about this side-splitting theorem here, and then 212 here in blue is this definition of the corollary and this stuff down here, okay? And so I want just to make sure you understand the difference there. Let's go ahead and just look at these. So this one right here, the side-splitting theorem says, a line parallel to one side of a triangle divides the other two sides proportionally. So you can see that this was like started out as a triangle ABE, okay, see that? And we've taken and put a line CD that is parallel to AB. And so what I can say here is I can say things are proportional. And so let's talk about this. It says AC, so this side right here, is proportional to CE. Okay, so it's over this side. And then the same thing applies to the other side as long as you match it up. BD is in a ratio with B or DE. And so you can see as we line them up here, okay, we have this proportion where like the little side matches up with the little, the big matches up with the big if you're looking vertically, so side to side, and then or horizontally, I mean side to side. Vertically, you're looking within the same side, and we say AC over CE and so forth. All right, here, so we're going to be finding missing side lengths, and here are some steps that I think were useful to finding missing side lengths. So you can see that we're going to write a proportion, and then we're just going to solve our proportion, okay? On some of the questions, you may be asked to find the entire side length, and the matter of just adding is all that it takes, and I'll show you some examples of this. Before I move on, though, and show you those examples, let's just quickly talk about what a corollary is. So a corollary is a proposition that follows directly from a postulate or theorem. And so what I'm saying here is that because we know this side-splitting theorem appears true, we can assume then that this works, okay? So 3 or more parallel lines divide two intersecting transversals proportionally. So now instead of just having 2 over here, you can see that we have 3 parallel lines. And so you can continue to add more parallel lines, and each section is proportional to the other side, okay? And hopefully you'll be able to see that with some examples, all right? So just understand that those mean proportional. Not congruent necessarily, but proportional. Excuse me. Okay, so use the side-splitting theorem to solve for x. This is x, BD or DB, And I know that I can set up a proportion, first of all, because that's what my steps tell me to do, but second of all, because of the side splitting theorem. And so let's go ahead and just do that. Write a proportion. Well, I like to stay on the same side, so I'm going to put x over 12. And I literally just wrote the x first because that one was what I saw first, and it was up there on top of the triangle. And then that equals, since I started with the x first, I have to then go to the 8 because that's the corresponding, that corresponds with the same position as x, okay? And then I put it over 10. And from here we cross multiply and divide. And so 12 times 8 and x times 10. So 12 times 8 is 96. And that equals 10 times x, which is 10x. And then my last step is to divide. And when I divide here, I get 9.6. And that would be my answer because it's literally asking for the value of x. Easy peasy, lemon squeezy, right? Okay, so then let's try this one. Well, what do you notice is different? Well, I notice that I have a minus 4 next to my x. But guess what? That's the only thing that's different. You are still going to solve this the same way by using proportions. So I'm going to go ahead and set up our proportion. And I'm going to do this rather quickly because I want to get to a few more things. And this is the same thing as what we just did. You're just going to see that we have an x minus 4 instead of just an x. Okay, so 6 times 21. I don't know what that is off the top of my head. 126 maybe? Oh, and of course my calculator. Yeah, 126. Okay, just making sure so I didn't tell you wrong. 126 equaling, and then remember this is where we have to distribute that 4 to the x, or 14, and to the negative 4. And so we say 14x, and it's minus 14 times 4 is 56. And, oh, I forgot my x, guys. Okay, and then I'm solving an equation. Okay, so I think you can do it from there. Let's continue on here. The last part here is, let's see, oh, not quite the last. Oh, and I can't go back. I wonder why it won't let me go back. Okay, well, since I can't go back, let's let's go to this one and talk about this one. And if we look at this, I'd have to start this whole thing over, and I do not want to start it over. So let me talk about this one, and I'll see if I can pull up another one. So PR is the whole side length, and that's the difference here that you have to be careful with. And then this little part right here is 9, and this little part is 6. Okay, so this one looks different because this is where we talked about that corollary, and we have the 3 parallel lines. But we still write proportions, guys. That's all we do. So I'm going to go ahead and write it as 9 over 18. Because remember, I like to stay on the same side. And that equals, now, what I'm trying to find is LT. So that's this whole side length, which is good for this problem because we have the whole side length on the other side. And so I can just set up a proportion and say, now I'm finding 6 over x. And then I cross multiply. So 18 times 6. And I get 108 equaling 9x. And then I divide by 9. And I see that x equals 12. I knew that. And so that is my answer because that is the full length. Now, I had another student today in class say, well, Mrs. Guyman, if this side over here is 18, okay, and this one is 9, that means this one has to be 9 too. And if that's 9, then to be proportional, this one has to be 6, right? Because they're the same. And so 6 plus 6 gives me my 12 here. And so, yeah, there's multiple ways to do these problems, guys. And that's okay. That works. as long as you get the right answer and you can justify what you're doing. All right, I think you'll be okay with the other questions. Basically, they were like this one, except for they gave you a smaller amount. So let me erase this, and I'm going to use this board. I want to tell you that this is, I'm crossing these out because we're going to attempt to justify this question now. Let's say that this is x, and this is 10, and this one is 2, and this one is, I don't know, 8. And I want to find that missing value for x, that missing side, PA. So once again, we still set up proportions. See how it's all about proportions? And that equals 2 over 8. Okay, so that's what the last slide was showing. That I messed up because I went ahead. Oh boy, and so this is 20 equaling 8x. Oh, my 0 did not want to write. And then we divide by 8. You guys have got this down now, I'm sure. All right, so you can see that if I was doing it this way, it would be 20 divided by 8. And we would get 5/2, or if I change that to a decimal, 2.5. And that's it. All right, that's it, guys. If you have questions, please address your teacher, send her an email, or let her know somehow in class. All right, see ya.